Here we have a system of three equations, and we're going to solve this system using addition. First thing we get to do is choose which variable we're going to eliminate, and we have to eliminate it twice. So we look at all the coefficients. So for the x's, we have 1, 2, and 2. For the y's, 2, 3, and 1. And for the z's, 1, 1, and 2. In this case, they're all pretty similar to the same amount of work. I am going to pick the z's because they do look just a little bit easier to me. And I'm going to pick those first two equations to do first. You eliminate the z's in pairs. So the least common multiple of 1 and 1 is 1. These two are set to go. We already have a positive 1z and a negative 1z. So we'll copy them down here. X minus 2y plus z equals 2, and 2x plus 3y minus z equals negative 3, and we add up the pair of equations. So we have 3x plus y, the z's cancel, equals negative 1. We have one equation without a z. We need another. So we need to pick a different pair of equations, so either the first and third or the middle and third equation to eliminate the z's. Let's pick the middle and third. It really doesn't matter. So the least common multiple of 2 and 1 is 2. Since our first equation is already, sorry, not the first one. If the second equation already has a negative 2, we want to make the middle equation there a positive 2. So to make a negative 1 into a positive 2, we need to multiply by negative 2. And we get negative 4x minus 6y plus 2z equals 6. And copy the bottom equation down just as it is. We get negative 2x minus 7y, and the z's cancel out, equals 7. So what we have created is a system with two equations and two variables. So our two equations are 3x plus y equals negative 1 and negative 2x minus 7y equals 7. So now we solve this system using addition, just as we have previously. We get to either eliminate the x's or the y's. In this case, the y's look a little bit easier, so let's do those. So we're looking for the least common multiple of 1 and 7. And that is going to be 7. Bottom one is already negative 7, so we want to make the top one positive 7. And we multiply that equation by 7. Giving us 21x plus 7y equals negative 7. Copying down the second equation, negative 2x minus 7y equals 7. Adding our equations up, we get 19x, the y's cancel, equals 0. Solving for x, we divide by 19, and x is equal to 0. Continuing to solve our system of two equations, we need to still find out what y is. So we take the x equals 0 and plug it back in to one of our original equations with two variables. So I'm going to plug it into that top one, giving us 3 times 0 plus y equals -1. So the 3 times 0 goes away. We just have y equals -1, and we found y. So our last step is then we're going to take the 0 for x and the -1 for y and plug them both into one of the original equations that we started with. And it doesn't matter which one, they will all work. I'm going to pick the first one, plugging in both the x and the y. We have 0 for x minus 2 times -1 for y plus z equals 2, giving us 2 plus z equals 2. Subtracting 2, z is equal to 0. Now we found all three variables, and our solution is 0, -1, 0. Let's try writing that 0 again. That's a little better. And we are done.